network issues there, sir.
Yeah, I will see. Wait.
Hmm.
Sorry, sir, because of network issue, it was lost.
No problem.
Yeah. You know,
Yes, visible.
with that, thank you, sir. So coming to the rehabilitation, it will relate to the example. If you're having any kind of cracks for a building because of some earthquake loading, so these kind of cracks can be prevented by injecting some epoxy glues into the cracks, whether the crack may be a wall, if not for a column or for any kind of beam also. And some of the damaged masonry portions, it can be removed out and it can be reconstructed back using the rich concrete mix. And some additional reinforcement means some extra side walls in order to make the walls to regain back its original strength. Increase strength of one structure, and coming to repairs, it will be done just to have some look appearance and it won't give the overall strength much. Into the retrofitting, so some of the historic monuments whatever there in the earthquake resistant zones or earthquake prone zones, and having the four different zones right now, 1 and 2, 3, 4 and 5 zones. So whatever the buildings that are there in earthquake zone 5, those are very the those are very much impacted for the sake of earthquakes or the seismic waves. So in order to make building resistance in those zones, we try to do these kind of retrofitting techniques. So already existing structure modified and make the building to be resistant to the earthquake loading. Of structures in the sense, laterally we can provide strength by adding some walls, if not columns, and eliminating some weak planes and asymmetric planning. So whatever the planning we are going to have any kind of building, we should have some symmetrical planning. If it is asymmetry in nature, for example, if you're having any kind of overhanging parts more in the building design, so what may happen means it leads to have an asymmetrical planning distribution. So whatever the moments generated, it to abrupt the stiffness that was generated by the beam column joints. So in order to avoid that, we can make these kind of retrofitting methods. What are the different techniques we are using in general? So global and local, we are classifying it. So globally, we can add the shear walls. If not, we can add the infilling walls for the existing structures, or adding up of bracings for already defined members and adding wing walls at the surrounding, and then wall thickening, increasing thickness of the actual wall. So by increasing the thickness, whether the dead load will be increased or not, we will going to see later on. And mass reduction, so loads at the entire building. Similarly, base isolation the local
Madam,
in order.
madam, your voice is not clear, ma'am.
Hello,
Ah, yes, no, madam.
sir, is it audible?
Oh, it's okay, madam, but just some disturbance is there, madam.
Okay, okay, fine, sir. Continue.
It's, yeah, continue, madam, continue, madam.
So some of the local techniques like jacketing of the beams and jacketing of columns and beam column joints, strengthening of individual footings. These are local techniques which are done in order to have the retrofitting of the building. So global perspective of the wall. So shear walls are the extra elements that are added at the sides of the walls in this nature. Here in the figures you can look it out. The element which was constructed for the part of the building, it will try to cause disturbance in the appearance. But still these are non-ductile reinforced frames. So by adding these kind of shear walls, we can make the building to get resistant for the seismic forces. So these kind of arrangement will give up an increase in the strength for ductile and stiffness of an building. Similarly, we can add some infill walls also. Already, this is one of the constructed existing frame. For this existing frame, we are going to add some packed mortar layout. Means we are going to construct a brick wall
Madam,
inside.
excuse me, madam. Excuse me, madam.
Yeah, sir.
Can you put your mic near to your mouth? Say, the voice is not clear. Flickering sound.
Okay, fine. Sir, is it okay?
Ah, okay. So please try to put your mic very near to you. Okay.
So, for an existing predefined frame, we are going to construct an wall inside. So whatever the new brick wall we are going to construct inside, these kind of new brick wall will be further packed with the mortars. So by arranging these kind of members into the predefined infilled wall, we are going to make the building get resistant for an earthquake loadings. So similarly, adding the steel bracings. So for example, if you look at this figure, you can observe a large number of openings are there. Just like if you assume any kind of frame which we are going to use for storing up the things like a godown. So here we are going to prefer some inclined bracings. So these kind of steel inclined bracings will try to protect the seismic loading. So whenever this frame will try to have the movement because of earthquake load, frames will make the building to move upon and again come back to its original shape. So higher strength in values and also very less in weight. So whatever the bracings we can arrange here, these can be of different types again. So here you can look at K type bracing, which will be arranged in the form of an K shape, and then channel bracing, which will be arranged just like rectangle panel, and X type bracing, literally one more X type bracing, and laterally formed beam bracings we can arrange. And coming to the wing walls, so this is one of the case study which was taken from Canada, one of the elementary school already affected because of earthquake. So how to make the building regain back its strength? We are going to increase the lateral strength by providing the stiffness at the sides. So ductility and stiffness of the structure will be increased by providing these kind of wing walls. So here we are going to design the wall and then we are going to arrange the wing panel at the sides based upon the column positions. So wherever we are having the column here, we are going to make the column to get standardized by using these kind of side extra projections. So we all know that the slab loading or the floor loading will transfer the beams and then to the column, and from the column it will be transported onto the foundation. So that's why we are going to make the column or select a column, and for column we are going to give some supportings here. So whatever the supportings we are provided, supportings will transfer the load to the surrounding soil condition environment also. So likewise, we are going to make the wing wall arrangement for the building in order to increase the ductility and stiffness of the structure. And wall thickening technique. So here we can see and one palace which was there in the Tripura. So whatever the wall, it was made with the brick masonries and mud in between the walls. In the ancient time, they used up these techniques to pair up the bricks. So whatever the wall we are having here, the wall strength was said to be reduced over day by day. So in order to increase the wall strengthening, we are going to use this kind of aluminum flat panels. So it will add the bricks, or it will add the strength for the walls. So these kind of aluminum panels, if not some addition of steel reinforcement, can also increase the wall thickening. So these kind of things can be arranged in vertical and also in the horizontal direction based on the construction. By this, we can avoid the sudden failure of the wall. We can increase the strength. So already predefined members which are made by using some of the standards, those kind of members can only be placed here, and by this we can increase the wall strength. And coming to the mass reduction. So mass reduction in the sense we are going to reduce the strength here, means one of the loading. So for example, if you're having G plus 3 here, by removing one of the floor loading, we can reduce the load onto the foundation. So as the building height increases, it will be much more going to get affected with the earthquake loading. It's the normal thing we all know. Whenever the building height will be more, then it will surely be affected. The top will surely be getting more affected by the earthquake loads. So that's why what we will do means we'll try to reduce the mass so that the loading will be reduced and the height will be come into consideration. So in this process, try to remove a story. So this top story is said to be removed, and it will increases the lifespan and also the strength of the building too, and it reduces the load on the foundation. So this is one of the technique which we can make the normal building to somewhat earthquake prone structure. Similarly, base isolation. So the isolation of superstructure from foundations can be known as the base isolation. So here you can look at the diagram. We are having a fixed base at the bottom. This is the isolated building, means we are placing some bearings in the bottommost portion of a building. So whenever building is said to be isolated, because of these kind of bearings, whatever the ground moment we are going to face on the building, for example, if you are having any kind of seismic load on the building, this seismic load will make the building not to get move upon or not to have any kind of shakings, vibration of top points. Whenever we are having the ground motion, the fixed base will be there, which make the frame to get settled there itself. It won't allow any kind of movement. Here you can look out in the diagram. When we provide the isolated base for the building at the bottommost foundation part, it will make the building to be in the standard structure. It was not making any kind of movements. So some of the bearings which we can see in general day-to-day life, those are the metallic roller bearings. So likewise, some rollers will be placed inside the bearing system. So because of these rollers, whenever we are having movements or ground is said to be moved because of the seismic waves, what will happen means these waves will try to come and be in contact with the foundation. So the foundation will make the columns or the beams to get move upon. The superstructure will try to move upon. So to avoid this movement of superstructure, what we are doing means we can create this kind of metallic rollers. So whenever the movement is there, the roller will try to move upon the side channel path which was provided in these gaps. So the roller will just try to move upon and it will try to absorb the seismic waves or the generated by the seismic waves. So it will have the displacement within this bearing itself. So the topmost superstructure or the building top portion won't move upon. So likewise, we can use the metallic rollers. Not only these kind of metallic rollers, here in this place, we can arrange up the rubber structures also. We can call them as elastometric isolators. So some of the rubber layers can be placed. So just like in the figure, we can provide some rubber layers, layered by layered manner in between these two columns. So the footing which was attached to the top column, whenever we are having the seismic energy, the energy will be absorbed by the rubber panels in between. So whatever the rubber panels we are going to have, these rubber panels will try to absorb the energy. It will try to have some compressions, so it won't make the energy to move back to the topmost portion or top to the building. So elastometric isolators, if not metallic roller bearings, can be arranged bottom of the foundation or at the bottom of the bottom of the building in order to take the seismic wave of energy. So the global retrofitting techniques, so which was used in the worldwide order. And to here, local retrofitting techniques, which are more predominantly used in the local area, mostly preferring these kind of local retrofitting techniques, which are somewhat lesser in cost and easy to handle. Not only easy to handle, the skilled manpower are already available in the market when compared to the global thing. So coming to local retrofitting technique, the main purpose is to increase strength for a building. So how this kind of increase in shear and fractural strength means we can use the jacketing process. So jacketing, one of the most method which was used nowadays in order to strengthen the olden building materials. So whatever the buildings which are old in nature, so those old buildings are said to be regaining back its strength by using these kind of jacketing process. So it increases concrete strength by increasing the flexural and shear strength of the building. So what are the general methods and what are the materials we are going to use while doing the jacketing means? First one is steel plates. and then the reinforced concrete, and then the fiber reinforced concrete wraps. And in general, in nowadays in the market, we are going to use these two main fiber reinforced polymers. So first one is carbon fiber reinforced polymer, and then glass fiber reinforced polymer sheets. So it will be just available in the form of 10 square feet of sheets. We can take that sheet and we can attach them to the walls, if not for the beam or for the column, to increase its strength. It is in the form of thin sheets, so it won't make any kind of much rude appearance, or it won't occupy much more space also. So right now is the FRP sheets wrapping increases the seismic energy absorption capacity of structural elements. So lots of researchers are going on right nowadays to know what kind of jacketing will increase the seismic absorption capacity of a building. So they are doing up the test based upon these kind of concrete jacketing, steel jacketing, fiber reinforced polymer jacketings. So coming to the concrete jacketing, so these kind of molds will be attached for the already pre-existing columns. So molds we are going to attach, we are going to place up the concrete into it along with certain ties and already reinforced new bars. So existing column. So at the left side you can observe the existing column. And in order to increase these existing column strength, we are going to create the column attached to it at the side by providing some additional reinforcement for the column. These additional reinforcement will be provided very close to this existing column by using some ties. So these are some of the ties which are useful to attach or hook for the olded column. So this is the normal practice which was right nowadays using in order to make the concrete get jagged over. So whatever the old reinforcement, we are going to add new reinforcement by doing welding connections to the bars. So some extra reinforcement. Here in the diagram you can observe. So new reinforcement and ties linking the new and existing reinforcement. So this is the old reinforcement inside already. So new reinforcement, we are going to tie upon both the thing. So like the concrete will be poured and filled in these gaps later on in order to make the jacketing process. So concrete jacketing we call it as. You are having jacketing which is known as steel. We are provide the steel. So these kind of steel reinforcement will be provided in the shape of panels, if not in the form of the rods also, steel rods. So steel reinforcement or steel cutting, it will refers to an encasing the member of steel plates, filling the gaps without any kind of non-string grout. So after placing these kind of members onto a column, all existing column we will select, which is less in strength. So those kind of column, we will take up the dimension of the column and then we cut up the steel panels, place up these kind of steel panels into it, and whatever the steel panels that are placed here, those steel panels will be further connected with the steel reinforcement also if needed. So it depends upon the conditions whether we require further steel panels or whether the reinforcement is also required. So likewise, we'll fix up these kind of steel panels at the top junctions. So here we had made up the steel panel reinforcement only at the top, but coming to here, we had provided both steel panel and steel rod reinforcement. So likewise, we can do retrofitting. So this is one more diagram which represents the beam jacketing. So horizontally, we are placing the reinforcement and inside we are providing small grout pipelines. So grouting, what do you mean by grouting? In the sense making thick cement paste and injecting it into the required position with high pressure. So because of making these kind of thick cement paste and filling it in the places wherever required or the voids wherever we are having, we can fill up the gaps. So here we are providing the reinforcement and inside we are doing up some grouting also. So similarly, the column, whatever we are going to make jacketing process, we will take the column and then we provide up additional reinforcement for the column. So adding some longitudinal reinforcement for the column. and adding some more transport reinforcement, and then pouring up the concrete throughout this column panel. So before pouring, we will arrange the formwork. We will make up the steel panels to get fixed at this concrete surroundings, and then we pour the entire concrete mix into here, so that the column size will get increased over. Not only the size, the column strength will also be increased by doing the jacketing process. So in some cases, we take the beam and we try to increase its strength by providing the mesh also. So not only the steel rods or steel panels, we can also provide the mesh in order to increase the load bearing capacity of an column or a beam. So the meshes can be arranged in this kind of 0 degree orientation, and in some cases it can be arranged in this kind of 45 degrees orientation. So 0 degree orientation of mesh and 45 degree orientations of mesh can be there. So because of providing these kind of meshes, we can increase the tensile load bearing capacity of the already existing building. This is how it look like. So the new bars we are going to place here, this red color indication will represent one of the front view of the thing. So the new bars we are going to provide, and floats along the beam will be reduced. If you take up a beam and wherever it was going to join the column, so this is the beam facing one of the left hand side or the right hand side facing position. So the floor will be removed upon, and the beam chips will be coated with the epoxy layout, and then we will place up the new bars into the beam, means new reinforcement will be provided, and then we do the shocketing. If not, the grouting process can be done by using some flowable concrete, just like the self compacting concrete likewise. So similarly, strengthening of the beam. So taking up the new bars again and making them with stirrups. So we are going to provide the stirrups and we will do the jacketing process. And while doing these kind of strengthening, we want to remember one of the point that the plastering of the beams and floors should be removed out. Means the old plastering should be removed. Then only we will have the proper bonding. And similarly, for any kind of cracked walls, if you are having a crack here, so what we will do in general means we just clean up the cracks and we provide up the grouting technique. By using the grouting technique, we try to make the thick cement paste and we try to fill it here. So if the crack width is less than we provide these kind of clamps or tie rods at the top and bottom portion. And then whatever the mortar we are using inside the concrete, the cement mortar, so these kind of cement mortar, it can be of micro concrete, if not 20 by 40 of thick concrete mix. So coming to the wire mesh, what we are providing, it should be of 50 and 50 openings. If the crack width is greater than 5 so then what we are going to do means we want to use the grouting process, but the grout what we are going to use, it should be in the 1:1, and it should be of non-shrinking grout, and then the tie should be of 300 to 4 center to center connected distance. So likewise, we want to provide the reinforcement for the sake of already existing structures, and then we want to fill up the gaps if required. So some of the existing cracks, whatever we are having, we can fill it by using routing process. And similarly, strengthening of footing and column. For any kind of building, the most important part means none other than the footing. Why? So in the sense, the overall load, it should be bared by the footing itself. So whatever the footing we are having at the bottom, so these kind of footings can be further get retrofitted by using any kind of techniques. The most important technique we try to use is these kind of column jacketing at the top, and then providing the bottom bars welded with 12 diameters. So bottom bars are going to be exposed at these kind of edges. So the red color marking shows us how the footings can be again placed using some additional bars. And after that, we want to do up some pull-out test also in order to know whether how strength enough it is of. Similarly, fiber reinforced polymers we can use. So whatever the fiber reinforced polymers we are going to use, these kind of fiber reinforced polymer. Hello.
Yes,
Madam.
Yeah. Sorry. So fiber reinforced polymer. So right nowadays, the researchers are going to do a lot of research in these kind of fiber reinforced sheets. So, for example, if you take an old building or historical monument, they are going to take the parts and dimension, they are going to design it in the 3D modeling, and after that they are providing entire sheets for the building. So polymer covered sheets are provided and they are testing the walls. So before retrofitting, you can look out the A diagram, wall stresses before retrofitting and after installation of steel window frames and additional fiber reinforced retrofitting. So when an additional fiber reinforced retrofitting was done for the walls, what was happening means concrete was not getting cracked. So you can look out here concrete cracking. So blue and then the green, yellow colors, orange, red. Red color indicates that much more cracks are going to get formed. So blue and green color indications represent that it was safe in nature. So much more safest parts we are going to obtain because of these kind of fiber reinforced polymer sheets. So here some of the examples are there, taking the column, and after taking the column we are going to fix the column by using the fiber reinforced polymer sheets. So this black color indications, it represents the fiber reinforced polymer sheets. These are just in of thickness, centimeter and of thickness, so that we can reduce the space occupied also. For example, if you do the jacketing here, what happen means the column size will get increased. It occupy more space. So rather than doing the jacketing process by using some steel or concrete, simply we can bring the material, the fiber reinforced sheets, and we can wrap the columns in this nature. So by wrapping up, what will happen means increases the strength of the columns. And while wrapping, we want to check out whether it should not have any kind of vacuum in between it. So similarly, some of the glass fiber reinforced polymer sheets also. So we, wherever we want to do up the retrofitting, we can take these kind of glass fiber reinforced polymer sheets, and also we can surround columns by using these kind of sheets, so that we can increase the load bearing capacity and also we can increase the strength of the columns. So finally, coming to the conclusion, right nowadays, wherever you're having more earthquake chances for any kind of areas, so in those areas we can prefer the global or local techniques based upon the situations and based upon the type of cracks that was generated. If not, we can take some preventive measures also. So if earthquake is more occurring in any areas, there we can initially construct a building using some base isolation techniques. So prevention is better than anything, right? So that's why we can prevent the construction. So we can prevent any building by using these kind of retrofitting techniques. And proper design code should also be followed while designing the retrofitting of any kind of constructions. So thank you, one and all.
Okay, thank you, ma'am. I
Yes.
request participant side. So if you're having any doubts, you can please ask, ma. You can ask to Neeraja, madam.
Yeah, any queries you can ask me. Anyone.
Yes, Nirja madam. So I want to clarify certain things.
Yes, sir.
So it's a nice presentation. So actually, how you will quantify the damage? There are few
So
questions for me. So you just throw some light. How you quantify the damage? First one. And if you
okay.
are quantifying the damage and if you are doing the experimental analysis to recover this damage or whatever it is, how you are doing scaling? And if you are doing any modeling, then how you are taking into the model. So actually this whatever you are telling is for the existing structure damage due to earthquake, right?
Yes, sir.
Existing structure, it is damaged due to earthquake. Then how to quantify this damaged this thing? So can you throw some light on this one?
So the thing was how to check the damage, if not how to quantify it. So for example, visually we can quantify different types of cracks in general. So whether we are having any kind of line cracks, if not the shear crack we are going to have. In other words, if inside the cracks anything was going to get formed, we can check out using some of the non-destructive testing methods also. By using ultrasonic pulse velocity methods, we can check out internal cracks formations. So based on that, we can evaluate. So what is the damage occurred? So much more experience is required in this field in order to show the quantitative nature of any kind of demolition or the cracks occurred. So the distress occurred in any kind of structure, the distress should be calculated based upon the quantity or which was visually observed, if not using some NDT techniques also. To my knowledge, I think I had clarified somewhat.
Okay.
Thank you, sir.
Okay, thank you, madam. So I
Yeah, thank
thanks
you so
Neeraja
much.
madam for sharing her knowledge with us. And thanks all the participants for staying more than half an hour to gain some knowledge. Okay, okay. Uh, so now I start the session. So tomorrow, same time,
Yeah,
we again join with some other new resource person. Thank you, and all.
Thank you, madam, for
yeah,
your
thank you so much, sir.
so inspiring the presentation. And I request the other faculty members, please come forward and deliver. Okay. So very good presentation, madam. Okay. Thank you.
Thank you so much, sir. Thank you one and all for attending.
Yeah. Thank you.
Sir, can I stop the sharing?
Yes, yes,
Yes.
madam.
Yeah, thank you, sir.